everyone. I have a pretty long video today. This is just me doing my studying of Godot, the what, why, and how. I just want to make a little template for myself as I'm learning Godot. As you can see, I have the first section is what, and Godot is a free open source engine. It creates the 2D and 3D platform games. We've seen it a lot. We've seen it with web fishing, I think X Zodiac. It also works with multiple platforms like mobile, desktop, web, and I just recently learned from the documentation they also take in controllers. I think controller like PlayStation, Xbox, and Switch controllers in case you wanted to use those for any games on Steam or any other sites, which is really great. This is just, I'm voicing over it. I'm so sorry, I'm horrible at voicing over stuff, but I'm in this video, just this small snippet, reading over everything, learning about the Godot engine, and getting started with the documentation, just trying to make a template for myself of things I learn and why I want to use it over, let's say, like RPG Maker MZ or other like Unity. I like what they say. I like to, like, just from reading this, that it's free, it's open sourced, that there's no attachments of licensing, buying subscriptions, or having to, like, again, yeah, for like APIs or stuff like that. I love that it's an open-based community. But as I was looking through the documentation, I just got really overwhelmed with the Godot demo projects and just all that there is. So I definitely took like a break after just kind of starting it up. But you know, step by step, that's all you can do. Take little breathers throughout it. And I just was looking for what's the best way possible to start looking into this, and that's why I thought the what, why, and how was a good start of just making sure I know what I'm getting myself into and not just throwing myself into the fire and burning alive. So I'm listing my reasons of why. I like that it's free. I love it. I like that although the documentation is like overloaded and I definitely got overwhelmed, I think it's a good thing that it has so much for people to just be able to look at the specifications. It means that it's really been covered well by a big community, which means you can get a lot of feedback and advice and mentorship, most likely, for anything and everything. There's always an answer to something, which is really great. So although it's really big, I'm happy that it's so nice, that it looks so, it's pleasant, and I can like read it out loud to myself, go over it, break it down, do what I have to do. And I was at first using RPG Maker MZ, but I don't know, my friend referred it to me, Godot, and I looked into just all the creations and what people have been able to create for it. And I just think it's a good, it's like a up and rising engine because of that whole Unity fiasco. So I definitely want to just get my hands on it, just start, you know, putting my brain to use, and I haven't coded in so long, and so I just want to be able to, if I'm going to code again, I want to be able to do this. So I'm moving on to the how. I said practice, videos, looking at the documentation, going side by side, following along, learning from all the different things that people discuss and topics of how to use it, the different tutorials they got, to making sure to take notes. I'm horrible at note taking. And here I'm just saying it's most likely going to be a long journey. It's going to suck at times. It's going to be great at times, but I'm going to do my best. I'm going to practice, and I'm going to make the most out of it, because this is definitely something that I want to do. I want to put my stories out into the world in a playable format. It's what I want to do. So I hope y'all enjoy. Alright, so let's go over this, shall we? Overview of Godot's key concepts. Every game engine revolves around abstractions you use to build your applications. In Godot, a game is a tree of nodes. A tree of nodes that you group together into scenes. you can then wire these nodes so they can communicate using signals. So it's a tree of nodes. So nodes, let's say they're like the fruits in a tree. And then you group together into scenes, which is the branches that hold the fruits. So scenes are the branches that hold the fruit. You can wire these nodes so they can communicate using signals. Okay. These are the 4 concepts you will learn here. We're going to look at them briefly to give you a sense of how the engine works. In the Getting Started series, you will get to use them in practice. Scenes. In Godot, you break down your game in reusable scenes. A scene can be a character, a weapon, a menu in the user interface, a single house, an entire level, or anything you can think of. Godot's scenes are flexible. They fill the role of both prefabs and scenes in some other game engines. Okay. Oh, wait, I forgot to play my little music in the background. Shout out to Mog on Mars. You're putting this. Sorry, forgot. Okay. So scenes are not technically like a moment in time, like a movie scene. A scene is more like, it looks like the object, because it can be a character, a weapon, a menu in the user interface, a single house, an entire level. It's like a box you can put a bunch of nodes into. So I guess like if I want to do the tree, it's fruits on the branch being the scene holding a lot of fruit. But I kind of like a scene being a big ass box and then nodes are inside there. And certain nodes might have signals that connect them to each other to work with one another. Like a character can have a node, a scene of a character can have nodes because a character's a scene, a weapon's a scene, but certain characters can only use certain weapons. Would that be the nodes then working to say, oh, like this character can only is like a 2-wielding master, so they can only have 2 wielding weapons, or this character is only a bowman, so an archer, so they can only use bows. I don't know, maybe I'm getting ahead of myself. Okay, so we have main menu. So the circles are scenes, I'm guessing. So main menu is one big scene that holds another box inside with the background, another box with the main in the background is the main screen. It seems to be moving. Okay, so background has the main screen. Context, which is the text that show up, and it says HBox container. This here, I'm assuming. Press, like a press button, the button. Center container, maybe like this one here or this one here. Any key, Xbox A, PlayStation X, and oh, you have to have certain, so if you want this to be a cross-platform. Oh, so you can use consoles. Interesting. Huh. Because Xbox, yeah, it's A. For PlayStation, it's X. And Nintendo, it's B? Really? Wait, let me look at my Switch right here. Oh my gosh, you're right. B is on the bottom. That's crazy. You can also nest scenes. For example, you can put your character in a level and drag and drop a scene as a child of it. Wait, what? You can nest. For example, you can put your character in a level. Okay. And drag and drop a scene as a child of it. I know about the parent and the child functions. I remember learning about that just in coding. But you're just saying the player can be reusable in certain levels. Like if you have a main character, you can use the player scene to put them in all the levels. And then if you have a different character, again, you can just reuse, reduce, recycle. Okay. So you don't have to keep creating new scenes for different levels. You can just reuse the same character. Okay. Nodes. A scene is composed of one or more nodes. Nodes are your game's smallest building blocks that you arrange into trees. Here's an example of a character's nodes. So I remember learning this from the tutorial, in the night tutorial, that you had to find their camera position. So you make a player scene, and then it's like, okay, do you want the camera to focus on this character, or are they just in the background? And then they have to have an image, like, okay, so we're following this character in a certain angle, but what are they going to look like? So then you have to import your sprites, and then collision is the bordering around the character. So like, can they go through walls, or they can't go through walls? And when they interact with things, when does it touch? And I remember doing that too. It is made of a character body 2D node named player, a camera 2D, a sprite 2D, and a collision shape 2D. The node names end with 2D because this is a 2D scene. Their 3D counterparts have names that end with 3D. Be aware that spatial nodes are now called no 3D, starting with Godot 4. Spatial nodes, I'm not sure what that is, but I'm sure we'll get to it eventually. Notice how nodes and scenes look the same in the editor. Nodes and scenes. Oh, they have circles. Are you saying because... Wait, do they? When you save a tree of nodes as a scene, it then shows as a single node. When you save a tree of nodes, it's like, this is a tree. Camera, sprite, collision. These are nodes. Okay. And it shows a single node with its internal structure hidden in the editor. Godot provides an extensive library of the base node types you can combine and extend to build more powerful ones. 2D, 3D, or user interface, you will do most things with these nodes. So node 2D has collision, animated, audio listener, audio stream player, canvas item, node 2D. So you're saying this node holds all of these things, right? And this scene holds these nodes. But you could have, because in this case this is a scene canvas item, right? And then the scene holds a node that holds these nodes because it's the tree. It shows a single node with its internal structure hidden in the editor, probably just to conserve spacing so it's not too cluttered and you don't have to scroll through so much stuff. So they try to just balance it out. Okay, once you made a node that has branches, we're gonna just put it all in one thing. Okay, that makes sense. That's if you're dealing with a bigger project and you start having, because they're gonna have a lot of nodes, especially if nodes are considered, or especially if scenes hold a bunch of nodes, and scenes could be either a character, a weapon, a level, a whatever you just said, a menu, a user interface, a single house. Like, they're gonna have, there's gonna be thousands of nodes you're gonna be using, so it makes sense that they would want to condense it into one. Okay, the scene tree. All your game scenes come together in the scene tree, literally a tree of scenes. And as scenes are trees of nodes, the scene tree is a tree of nodes. Wait, let me read that one more time. As scenes are trees of nodes, right? Boxes that hold a bunch of ornaments. The scene tree also is a tree of nodes. But it's easier to think of your game in terms of scenes, as they can represent characters, weapons, doors, or your user interface. It's also a tree of nodes. Because it's like a thing within a thing within a box within a box within a box, is what you're trying to say. Which is a little hard for me to... Okay, sorry, I'm already struggling. I haven't studied in so long, so this is me trying to get back into a studying habit, and I'm like... Okay. Yeah. I just hate that they say scenes, because I just think of like a moment, an instance. You know, scene 1. act 2 scene 3. That's what I think of. And now you're saying these scenes are like character, weapon, doors, like objects. I feel like they're just objects. So I don't see how it's easier to think of as scenes, but I'll try to build a habit to say scenes because that's what they say. So signals. Oh wait, let me look at the image first. Okay, level 1 is a scene. With background layer, texture. Are these scenes too? Character body 2D, that's a scene. Okay, so level 1 is a scene which has scenes in it. Right, because you have the character in level 1, you have a portal 2D, you have coins, you have enemies. These are all scenes. You have a tile map, is that a scene? And I'm guessing background layer, texture, rect. These are scenes as well. Because if you look back here, these are background, main screen, these are scenes in a scene. So you have the parent, and then the children inside. Something like that. Okay. So, signals. Nodes emit signals when some event occurs. Okay. This feature allows you to make nodes communicate without hardwiring them in code. Okay. It gives you a lot of flexibility in how you structure your scenes. Area entered, area. Okay, so when you hit a certain, in this case, these are signals that you can create. So that when you do, like, so if a player, let's say this is the exit, a player goes and passes the exit, a signal's like, hey, area exited, so take them out, and then body entered the next area that's on the right side or something like that. I'm going to assume. We'll get more of a handle later. Signals are Godot's version of the observer pattern. You can read more about it here. What's the observer? Oh, that's not. That's my Godot thingy. I can't see. Okay. Model view. Observer is so pervasive that Java put it in its core library, and C# baked it right into the language. Observer is one of the most widely used and widely known of the original Gang of Four patterns, but the game development world can be strangely cloistered at times, so maybe this is all news to you. In case you haven't left the Abbey in a while, let me walk you through a motivating example. Say we're adding an achievement system to our game. It will feature dozens of different badges players can earn for completing specific milestones like kill 100 monkey demons, fall off a bridge, or complete a level wielding only a dead weasel. Ah, okay, so yeah, signals are also for achievements. That makes sense, because the game has to keep in memory of these things, and it's like, oh, you've hit something. This is tricky to implement cleanly since we have such a wide range of achievements that are unlocked by all sorts of different behaviors. If we aren't careful, tendrils of our achievement system will twine their way through every dark corner of our codebase. Sure, fall off a bridge is somehow tied to physics engine, but do we really want to see a call to unlock fall off bridge right in the middle of the linear algebra in our collision resolution algorithm? Oh. Because then you can break the game with this kind of thing. What we'd like, as always, is to have all the code concerned with one facet of the game nicely lumped in one place. The challenge is that achievements are triggered by a bunch of different aspects of gameplay. How can that work without coupling the achievement code to all of them? That's what the observer pattern is for. It lets one piece of code announce that something interesting happened without actually caring who receives the notification. Huh. It lets one piece of code announce that something interesting happened without actually caring who receives the notification. So you don't want to put achievement, like in level 2, if there's like a certain achievement that you can get specifically in level 2, they're saying it's better not to have this kind of function in the level at all. It's better to have an observer just say, hey, this happened, that's it, because then it could cause a disturbance in the level. I don't know, something about like it just can be what they said, coupling the achievement code to challenges that are triggered by a bunch of different aspects of gameplay. Yeah. Okay, I get what you're putting. I'm picking up what you're putting down. It's just hard for me to explain. But let me go ahead. They're gonna say, for example, I'm sorry. I'm thinking, making my own example, and then they are like, hey, we already actually had something written for you. For example, we've got some physics code that handles gravity and tracks which bodies are relaxing on nice flat surfaces and which are plummeting toward sure demise. To implement the fall off a bridge badge, we could just jam the achievement code right in there, but that's a mess. Instead, we can just do void physics update entity ampersand entity. I remember the ampersand. I do remember an ampersand. This is C++ type shit. Physics colon class. This is like a class, right? Update entity ampersand. This means like the direct object. I think ampersand puts it in the direct object of the variable entity function. I have to remember, I have notes from when I interned with Microsoft of just learning C++. I have to remember how this is, what this all means again. But this is the variable. This is its class. Like, you know how like there's like int or string, that's like a class, and so this is class entity ampersand, and we're directly touching it. It's not a pointer. A pointer is an asterisk. Ampersand means like we're directly accessing in the class entity variable. And then a boolean, which is a true or false, was on surface equals entity dot is on our surface. So if this is true, so was on surface equals entity dot this here is on our surface. Entity dot accelerate. So if that's true, entity dot accelerate gravity, which means we're pulling them down a lot more. And then entity dot update. So we're adding accelerate gravity to the entity variable, and then we're updating it, so now that accelerate gravity is permanently on entity update. If was on our surface. Oh, I remember. Okay, so this is a boolean. We're creating a boolean variable called was on our surface, which holds entity dot is on our surface. Then we accelerate the gravity on the entity. We update the entity tab accelerate gravity. Then we ask if this boolean was on surface is true, and it's not, the entity is on our surface is not is on our surface. Because you're saying entity dot is on our surface, saying if we have triggered this boolean and this isn't on the surface, notify entity, the variable, event start fall. Okay. I'm starting to piece it together. Surface, then accelerate gravity and update if was on their surface. Double ampersand means and, so they both have to be true. Entity is on our surface is false, like is not, because it's saying no, not, and not entity dot is on our surface. Because if you accelerate gravity and they're falling, right, then that means they're not on the surface. Then notify entity event start fall. All it does is say, I don't know if anyone cares, but this thing just fell. Do with that as you will. Okay. I love how okay, but like, see, I have to talk it out first before I read the answer. Like, I need to remember how to even just read code like this. And make sure I understand what's going on. So yeah. I don't know if anyone cares, but this thing just fell. Do with that as you will. The achievement system registers itself so that whenever the physics code sends a notification, the achievement system receives it. So physics code, okay. It can then check to see if the falling body is our less than graceful hero, and if his perch prior to this new unpleasant encounter with classical mechanics was a bridge. If so, it unlocks the proper achievement with associated fireworks and fanfare, and it does all of this with no involvement from the physics code. In fact, we can change the set of achievements or tear out the entire achievement system without touching a line of the physics engine. It will send out its notifications, oblivious to the fact that nothing is receiving them anymore. Oh, that's pretty cool. How it works. If you don't already know how to implement the pattern, I don't. You could probably guess from the previous description, but to keep things easy on you, I'll walk through it quickly. Thank you. The observer. We'll start with the nosy class that wants to know when another object does something interesting. These inquisitive objects are defined by this interface. Class observer. Yeah, see? So like this, entity is a class. Class observer. It's a public class. Virtual, and I forgot what this does. Observer, okay. Virtual void, on notify, a const, meaning this is unchangeable. You can't change this, it can't be updated. Oh, interesting. If it can't be how did you update it if it can't be updated? Void on notify const entity ampersand entity event event class event equals 0. Huh. But you have it here, update entity. I thought we couldn't do that. I forgot what void does specifically. I remember why we do void. But, Alright. On notify. Is that what this notify thing? Notify entity event start fall. Let's keep reading. Okay. But this is just setting up the observer class. Any concrete class that implements this becomes an observer. In our example, that's the achievement system, so we'd have something like so. Class achievements public observer. Okay, class achievements public observer. This connects it somehow. I just can't remember the colon. What that specifically. But it's saying that class achievements is an observer. And the public functions we have is virtual void on notify. So we have this. We are taking from the observer class and we're implementing it, this function, into the class achievements from public observer. And then we're having a switch event. Case event entity fell. If entity dot is hero and hero is on bridge, unlock achievement fell off bridge. Break. Handle other events and update heroes on bridge. Private. Void unlock achievement. Unlock if not already unlocked. Okay. Boolean hero is on bridge. Okay. So you're adopting this function and they're saying, oh, okay, so if class achievement, if this was notified in the previous code, which we have notify, and the observer is like, oh, hey, yeah. And the achievement's like, oh, it was called, and this is the correct statements, then yeah, okay, we'll unlock it. And unlock, void, unlock, achievement. Unlock if not already unlocked. Okay. The subject. The notification method is invoked by the subject being observed in Gang of Four parlance. Parlance? Okay. This is a nice little C++ review. Oh yeah, who don't know C++ is? I love that I got to actually experience C++ for 5 months. Thank God, or else I would not understand any of this. Okay, the subject. The notification method is invoked by the object being observed, right? In Gang of Four parlance, that object is called the subject. It has 2 jobs. First, it holds the list of observers that are waiting oh so patiently for a missive from it. Okay, class, subject, private, observer, asterisk, a pointer. So this observer class is pointing to observers, max observers. So it's not the actual, like, because ampersand means you're touching the class directly. A pointer is saying like, hey, this is coming from this, but we're pointing to this new, what they call it? Like data address. It's like data address, I think. Ampersand is like the direct data address. An asterisk is pointing to another data address. So we're not actually like changing the observer class. We're pointing to a different data address that will hold observers, max observers, or something like that. And it holds the integer number of observers. So that, okay, so because it's like if you have like an observing class, you need like for different list of observers that are waiting for a missive. So let's say like level 2 has like 5 possible achievements, and you need 5 listeners or 5 observers to calculate for these 5 specific achievements. So you're gonna need this kind of class subject, I'm assuming, for that. For each one to be able to listen and then be like, oh, these are different data addresses, but they're all gonna point back to the subject class, which will come back to the achievements and be like, hey, level 2, we got 5 achievements cleared. So something like that, maybe. I'm just thinking. But anyway, the important bit is that the subject exposes a public API for modifying that list. So wait, hold on. The notification method is invoked by the object being observed. In Gang of Four parlance, that object is called the subject. It has 2 jobs. First, it holds the list of observers that are waiting oh so patiently for a missive from it. Okay, the important bit is that the subject exposes a public API for modifying that list. Subject, public, void, add observer, observer asterisk observer, add to array. Remove observer, observer asterisk, remove from array. Okay, so if we need another observer, we're gonna add, okay. That allows outside code to control who receives the notifications. The subject communicates with the observers, but it isn't coupled to them. In our example, no line of physics code will mention achievements, yet it can still talk to the achievement system. That's the clever part about this pattern. It's also important that the subject has a list of observers instead of a single one, and make sure that observers aren't implicitly coupled to each other. For example, say the audio engine also observes the fall event so that it can play an appropriate sound. If the subject only supported one observer, when the audio engine registered itself, that would unregister the achievement system. That means those 2 systems would interfere with each other, and in a particularly nasty way, since the second would disable the first. Supporting a list of observers ensures that each observer is treated independently from the others. As far as they know, each is the only thing in the world with eyes on the subject. So like if you're on Steam and you get an achievement on Lethal Company, and you know how like the Steam, like it pops it up in that bottom right corner with the or whatever. So they're saying you get one observer to actually pop up the achievement text and another observer to like make a sound for it. Because if you try to put them both on the same observer, the same subject, it would cancel the other one out. They can't do it at the same time. The other job of the subject is sending... Okay, so... Oh, so subjects are important. So you have the observer class. Okay, that is the one to notify to achievements. So we have the achievements, we have the observers, and we have the subjects. Or observers and subjects. So subjects have a list. So it's achievements, subjects, and in the subjects we have observers. And each observer will listen out for, oh, they fell off the bridge. The text observer is going to be like, oh, we got it, and give it to subject. And then the sound observer is going to listen and then give it to subject. And then some. And then the subject is able to be like, okay, we got the text and sound approved. Go ahead and send it to achievements. Then achievements notifies on the bottom right with the text and sound that an achievement was made. Is what I'm understanding. The other job of the subject is sending notifications to the achievements, I'm assuming. It's classed subject protected, void notify, const entity, ampersand entity, event, for int, for number. Okay, so for the variable I equals 0, if I is, oh my gosh, can I? I think that's less than. Guys, I don't know my signs. Hold on. I keep having to double check. I'm horrible. Okay, that is less than, thank God. Okay. I'm really bad at that. It has to eat more, so it has to eat because it's less. It has less food. Okay. If I is less than number of observers, increment I. So for integer I equals 0, if it starts 0, if I is less than number of observers, we have to increase I. Increment I, that's what it means. And then observers, and this is a loop, I'm assuming. Observers I, if it's 0, 1, 2, or 3, on notify entity event. Oh, is that what I was talking about? Like if there's more than one increment. So we have observer 0, this, the text, observer 1, which is the sound, and then observer 3 is like a little effect. And then they all get notified to the entity event. Maybe? Observable physics. Now we just need to hook all of this into the physics engine so that it can send notifications and the achievement system can wire itself up to receive them. We'll stay close to the original design patterns recipe and inherit subject. Okay, class physics, public subject, public void update entity from okay, inherit subject into the physics class. This lets us make notify in subject protected. That way the derived physics engine class can call it to send notifications, but code outside of it cannot. Lily, the derived physics. In real code, I would avoid using inheritance. Instead, I'd make physics have an instance of subject. Instead of observing the physics engine itself, the subject would be a separate falling event object. Observers could register themselves using something like default add observer this. To me, this is the difference between observer systems and event systems. With the former, you observe the thing that did something interesting. With the latter, you observe an object that represents the interesting thing that happened. Okay, some of this is flying over my head, but I'm understanding like the basic idea, the general idea of what's going on. This lets us make notify in subject protected, the way the derived physics engine class. Now, when the physics engine does something noteworthy, it calls notify, okay, like in the motivating example before. That walks the observer list and gives them all the heads up. Yeah, okay, achievements. It sends it to achievement. So subject has the observer 0. Yeah. Oh wait, but is variable 0 achievements and then audio's 1? Oh, interesting. I thought it would be like it would give us text, audio to give to achievements, but okay. So the first variable will be achievements, and then it comes with audio and text, or maybe achievements is the text. No. Pretty simple, right? Right, of course. Yes, it's not like I took like 30 minutes to read this. Just one class that maintains a list of pointers. Pointers to instances of some interface. It's hard to believe that something so straightforward as the communication backbone of countless programs and app frameworks. But the observer pattern isn't without its detractors. When I've asked the other game programmers what they think about this pattern, they bring up a few complaints. Let's see what we can do to address them, if anything. Oh, this is a really long article. This is actually super long. Oh my gosh. Okay. Maybe I don't need to go too in depth about this. I was just curious what they had to say. Yeah, I was just curious what they had to say about signals. I'm so sorry. I was very clear to the summary. I'm so sorry. So let's just reread this real quick. Signals. Nodes emit signals when some event occurs. This feature allows you to make nodes communicate without hardwiring them in code. It gives you a lot of flexibility in how you structure your scenes. For example, buttons emit a signal when pressed. You can connect to this signal to run code in reaction to this event, like starting the game or opening a menu. Other built-in signals can tell you when two objects collided, when a character or monster entered a given area, and much more. You can also define new signals tailored to your game. Oh, like if you're like walking against a wall and it's like like, you know, like how like in Pokemon I think they do that to let you know like, oh, you can't go past this. Summary. Nodes, scenes, the scene tree, and signals are 4 core concepts in Godot that you will manipulate all the time. Nodes are your game's smallest building blocks. You combine them to create scenes that you then combine and nest into the scene tree. You then use signals to make nodes react to events in other nodes or different scene tree branches. You combine and nest signals to make nodes react to events in other nodes or different. After this short breakdown, you probably have many questions. Bear with us, as you will get many answers throughout the Getting Started series. I get something about it, but it isn't clear what they want to. I like the community already has a lot. That's what I'm saying! Oh, that's what I'm saying. That's literally, I agree with you. I literally said exactly what you said. 'Cause scene, I think of an instance in a movie, in a plot, in a story. Like, that's what scenes are to me. So to call a scene like an object, or an object a scene, it's weird. Oh, the terms object or entity wouldn't be descriptive enough, I guess. Unity's prefab is probably the closest term, as documentation itself mentions, but maybe Godot's developers didn't want to copy it. I don't know. And for lack of a better term, I suppose at first the reasoning was as follows. We compose a node tree into a scene, but this scene could be made reusable in the end, so why not make it possible to insert a scene into a scene? I think the main controversy comes from the habit of understanding scene as something presented on the screen, and usually occupying the entire screen as this given moment of time. As is, yes, but technically, for example, a scene containing only the main game character, a character prefab, in Unity's terms, is still a scene. Example, you can also present it on the screen standalone, although by itself it doesn't make much sense. Perhaps a more practical example could be thought out, like when one scene could be a standalone scene, and also use the prefab. Interesting. Okay. I mean, I guess. I'll try to get used to it. I'm with you, buddy. I'm so with you. Oh, goodness. Sorry. Oh, I guess I kind of skipped introduction to... Well, I did do this. What is Godot? What can the engine do? How does it look and work from the human languages? Wait, what the heck? I didn't see this. I just skipped so much stuff. Oh, I went straight to the step by step. So they're like, yeah, you need to like look into this first. My bad. You need good programming foundations. While we try to make the engine accessible, you will benefit a lot from knowing how to think like a programmer first. Godot relies on object-oriented programming paradigm. Being comfortable with concepts such as classes and objects will help you code efficiently in it, which I learned in C++. But I only had like 5 to 6 months in C++, and I've already forgotten a lot of how it works, but I can still kind of read it. If you are entirely new to programming, we recommend the CS50 open courseware from Harvard University. I did that! It's so fun. It's a great free course that will teach you everything you need to know to be off to a good start. It will save you countless hours and hurdles learning any game engine afterward. You'll learn multiple programming. Don't be afraid of that. Programming languages have many similarities. The skills you learn with one language transferable to others. I think this one, CS50, is for Python, so it's not C++. But learn how to code with GD script, and C#. Okay, I never tried C# actually. Like, it'll be a little faster and easier. Okay. While GD script is a language specific to Godot, the techniques you will learn with it will apply to other programming languages. Note that it is completely normal for a programmer to learn and use multiple languages. Programming languages have similar... Yeah, you said that before. I have only done Python, JavaScript, and a bit of C++. But I haven't touched code in a long time, and it's very much like track. Like as an athlete, if you miss like a week of practice, your body's completely out of shape. It's the same thing, where I haven't coded in months, and now I feel like a baby at code all over again. But hopefully everything will start snapping back into place for me eventually. To learn GD script, you can use the app Learn GD Script from Zero. That's so awesome! No way! It is a complete beginner course with the interactive practices you can do right in your browser. Oh, you guys are so cool. Wait, are you serious? Oh, you guys are awesome. Hold on. My thing's in the way. Oh, whoops, sorry. Oh my gosh, that's so amazing. Oh, it's me. Wow. No way. Oh my gosh, I can do a whole like video just on this alone. Oh, beautiful. Oh, very, very nice. Yes, learning to program can be daunting, yet you want to make video games, so there is no way around learning to program. Every video game is a computer program. Telling the computer what to do. Programming is the process of writing precise instructions that tell a computer how to perform a task. A game's instructions are, for example, moving a character, drawing a life bar, or playing a sound. To do any of that, you need to learn a programming language, a specialized language to tell the computer what to do. Ugh, VAR. I was part of Ada Developers Academy, and they hate VAR. They've always said, just don't ever use VAR. And I forgot why. I even forgot what VAR does. If I VAR class Python. Let me just look at what it was. Are you generating? In Python, there isn't a var keyword like in some other languages. However, you can achieve similar fun using different concepts depending on the goal. Oh, how about JavaScript? Okay. Var, let, and const. Ah, yes, the let are used to declare variables, while class is used to define a class. Oh, okay, okay, so it's not a, I'm so sorry. Var is not a class, it's a variable. It's an object, right? Because you're making a variable into it, because you can say let. Const is like you can't change it. Let, you can manipulate what you want it. Like it can be updated, it can be changed. Like you can actually, it's tangible. Var is like, I don't know. Scope, function scoped. If declared outside a function, it becomes a global variable. Hoisting. Hoisted to the top of its scope, which means it can be used before it's declared. Redeclaration can be redeclared within the same scope. Oh, so it's a very open one. Scope, block scoped. Block scoped. It is only accessible within the block it's declared in. Hoisting, not hoisted, meaning it cannot be used before it's declared. Redeclaration cannot be redeclared within the same scope. Const, block scoped. Hoisted, not hoisted. Redeclaration cannot be redeclared. Value must be assigned to a value when declared and cannot be reassigned. So var is like a very, oh, that's probably why they said don't use it, because it can be used anywhere. It's very open, which means it's more subject to causing problems down the road, especially if you're redefining stuff and you name a var for something earlier on or later on, but you know, it can be called before it's declared. So it can cause you a lot of issues unless you just know how to, they say use it very, I think even when I was at Microsoft too, they said don't be very gentle, like, or avoid it at all costs if you can, because just having a global variable is a dangerous thing, especially with a huge code base. It can be difficult to manage. So okay, use it sparingly. Like don't just declare everything a global like a var. Like it's better to use lets and consts, things that can only be kept within their own blocks, so it doesn't get confusing and you're not searching for whatever var is causing issues in your code. So that's why they say you have to use these sparingly. Just to double check, they say using var sparingly. Can help avoid bad habits and make code more readable. Yeah. When the variable's type is unclear, if the initializer doesn't clearly indicate the type, use an explicit type declaration instead. It has problematic scoping rules, and they are hard to understand. For this reason, it was softly deprecated. That means it is generally not a good idea to use var. It still exists to not break a lot of the internet and relies on the old variable scoping rules. See, by using var, developers can avoid having to explicitly specify the data type of a variable, which can make the code more readable and easier to understand. But I feel like that's like, you want to explicitly specify. Like, I think you should always be as specific as possible. I don't think it makes it any more. It's so funny how they both say completely different things. if it's obvious, but like sometimes it's not obvious. Like what makes it, who says it's obvious? Who is the judge of obvious statements or obvious typing? Not me. Okay. So anyways, don't use these. I don't agree. I don't like that they use this. But whatever, teach their own. So we got random angle degrees. So these are integers. Max range, max bullet speed. Function shoot. The bullet variable equals bullet scene dot instantiate. Add child bullet. Huh? Add child. Oh, this? Oh, like we're putting the parent function is shoot and we're adding in shoot the bullet variable here. We're adding this, I'm guessing, into the shoot function. Bullet dot global transform equals global transform. Yeah, I don't know what that means. No idea, but I at least understood this. Programming languages are different from natural ones like English or Spanish. The computer does not think. Unlike us, it can't interpret what you tell it. You can't tell it something vague like draw a circle. Well, now with AI, you kind of can. Which circle? Where? Which color should it be? How big should it be? The computer needs exact instructions. To draw a filled circle, the computer needs to know exact drawing coordinates, the radius, the thickness, and the color you want. The code to do so may look like this. Click the button to run the code example and see the result. Draw circle, vector 2, 0, 0, 60, xy, color dot aqua, vector 2, what that does, coordinate 0, 0, 60. I don't know what the 60 does. Like, is that like the amount that it wants to fill? Okay. In the following lessons, you'll learn how this code works. For now, we want to give you a sense of what computer code looks like. In this example, everything matters. Each parenthesis, not parentheses, it would have been E. Capital letter, period, and comma. The computer always does exactly what you tell it to. No more, no less. It blindly follows every instruction. When you program, you're the one in charge, and you're free to do anything you want. How do you give instructions to a computer? Using a program language and precise instructions. You're right! You'll learn to code with GD script. In this course, you'll learn the GD script programming. I'm sorry. You'll learn the GD script programming language. The name stands for Godot script. This is a language by game developers for game developers. You can use it within the Godot game engine to create games and applications. It's the language used by games like Dome Keeper and Brotato. Engineers at Tesla also use it for their card stash parts. GDScript is an excellent language to get started with programming because it's specialized. Unlike some other languages, it doesn't have an overwhelming amount of features for you to learn, like C++. Holy shit. Most programming languages are similar. Yes, don't be afraid of being locked in. The concepts you learn in your first programming language will apply to all the others. Most languages have more similarities than differences. Yes, yes. Here's an example. GDScript, JavaScript, and Python. Yay! 2 of which I've already done. Try to spot the similarities and differences. Func is definitely C++. Take damage amount. Health decrements amount. If health is less than 0, die. Function take damage amount. And then, okay, so you guys use the same colon thing. So instead of having the brackets, oh, the brackets kill me, man. I hate the brackets. But also, you need a semicolon to end it. I'm pretty damn sure in JavaScript that was always a thing. You had to have a semicolon to end it. Same with C++, I think. You do not leave those unended. But I digress. Health decrement amount. If health less than 0, die. Yeah, they have brackets, and then these have... That's why I like Python more, just because I just like the colon, and it's just like, in this block, here you go. The brackets can kind of get a bit confusing. when you start stacking them. Define, take damage, amount. Yes, yes. And I like define, but we have to deal with function. It doesn't look that different, does it? Are programming languages all completely different? No, they have many similarities. This is a course for beginners. If you want to learn to make games or code but don't know where to start, this course should be perfect. I have some experience, but again, I just think it never hurts to just relearn stuff and to, you know, to humble yourself and go back to the training wheels. I highly think it's intuitive and integral to always go back to the basics and always relearn and solidify your understanding. Even if a lot of this stuff I'll remember, but you know, it's important. We designed it for absolute beginners, but if you already know another language, it can be a fun way to get started with Godot. Exactly. We will give you the coding foundations you need to start making games and applications with Godot. Please be patient. It will take time before you can make your first complete game alone. This is so true. Thank you. Thank you for giving that heads up that it's okay to be slow. Like, it's okay, because it's better to not rush it, because if you rush, it's gonna suck. Like, everything's gonna go over your head if you like try to cram everything with AI and asking AI for the solutions. It's like you're not learning anything. You need to be able to learn, solidify your understanding and grow in it, make a foundation that's solid. Learning to make games takes practice. Creating games is more accessible than ever, but it still takes a lot of work and practice. Do not expect any single course or book to turn you into a professional. Programming is something you learn through practice. If something doesn't make immediate sense, don't stress it too much. Keep learning and come back to it later. Enjoy the process and celebrate every little success. You will never stop learning as a game developer. I love you guys. Thanks for saying that. What and how you'll learn. In this free course, you will... I love that this is free. Thank you. I appreciate that. In this free course, you will learn the foundations you need to start coding things like these. Inventory, healing heart, gems, sword, a little maze thing. Oh, very nice. Along the way, we'll teach you some of the mindset you need as a developer. Too many programming courses skip that essential part. How to write GD script code, essential programming foundations to get you started. As you go through the course, you will have many questions. We will answer them as the best we can as we go. But there is so much to cover that we have to take a few shortcuts. We don't want to overwhelm you with information. Thank you. We also want to respect the pace at which our brains memorize things. We broke down the course into short lessons and practices. If we put too much into each part, you'd learn slower. If at any time you're left with burning questions, you're more than welcome to join our Discord community. I'm scared! I will eventually, at some point, once I actually like start coding. Alright, I'll do it. But for now... Oh, is this good for Godot 4? What you'll learn in this free course is fully compatible with Godot 4. While we initially designed this series for Godot 3, the foundations of GDScript are still the same in Godot 4. Okay, good. I love that they updated that. Programming is a skill. Programming is a skill, so to get good at it, you must practice. It is why we built this app. Each lesson is followed by an interactive practice to use what you learned. Speaking of which, it's time to look at the practice screen. To continue, click the practice button below. It will give you a short run through how practices work. Try your first code. Run your first bit of code and see the results. Oh shit. We prepared a code sample for you. For this practice, you don't need to change anything. To test the code, click the run button below the code. Well done. You completed. Print welcome. Well, where is the welcome? Click the run button. Oh, right there. Are you doing today? All right. Continue. When you program, you're bound to run into errors, tons of them. But you shouldn't worry. On the computer, errors are a good thing. You will encounter errors, and that's okay. Every programmer does, especially professionals. At school, maybe you learned that mistakes are a bad thing. When you code something, it's not the case. Errors help you write correct programs because they show you what is wrong in your programs. A code error looks like this. It's a message that tells you some bit of your code doesn't work. The function move already exists in this class at line 22. Making errors friendlier. Oh my gosh, I can't talk anymore. I'm already hitting like an hour of studying, so I'm kind of like, see, isn't it sad that it's only been an hour and I'm already kind of over it? But I'm not over it. I'm excited, but I'm just tired, and I'm like, my brain is having a hard time to just stay focused, even though I want to be focused. It's a battle. Anyways, making errors friendlier. Error messages can look a bit cryptic. This is because they're designed by programmers for trained programmers. We added an error translator in this app that will help you get started. It shows you why an error happens and what the message means. It also gives you some tips on how to fix it. Oh, that's nice. Error messages are designed... Oh. Very nice. It's very sweet. Error messages are designed on purpose by fellow programmers who came before you. That's nice. They anticipated you might have specific issues and wanted to help you fix them. Programmers are so cool. They didn't have to do that. No one had to tell you, like, imagine like the first ever programmers that didn't have those errors like at line 436, and they have like an 800 lined file of code. They didn't get to know what line it was that was causing the problem. They had no one to tell them. So the fact that they implemented a whole system to help you and tell you, hey, at line 436, you got this problem over here. You should go check it out. And they, you know, they highlight it for you and everything. It's like the nicest thing ever. And I'm like, programmers are like angels, low key. Or at least the founder programmers, I think, are angels to have created a system to help you out. The future you, like the future programmers in the future. I can't talk anymore, but you get what you catch my drift. I think that's so lovely. So open source, so mindful, so considerate. You shouldn't think of errors as failures. They are like mentors helping you from the past. Aww. My ancestors. Importantly, errors won't break your computer. At least not with GDScript, because it's a pretty safe language. Ultimately, you want to fix all the errors in your program. Understanding what is causing the errors with the help of error messages is key to fixing them. Are error messages a good or bad thing? They're good. They're here to help. Okay, let's see an error in action. Once again, click the practice button below to face your first real error. Fix your first error. This code is incorrect and will cause an error when you try to run it. The code defines an empty function named "this code is wrong." To work, the function should use the return keyword, but this function is currently inside a comment, which the computer ignores. Test the current code by pressing the run button. Oh. Yeah. In C++, I think it's this. Or it's... No, C++, I think it's hashtag. I think Python does /. If this code is wrong. Or we can make a boolean. Hold on. Okay, it looks like they're doing underscore is right. Equals true. If code is right, return. Uh-oh. Parsing expression misplaced built-in type in error line. Dang. You get this error when you wrote something that is syntactically invalid or you are missing something to complete the line of code. Oh, how do you, okay, then how do you define? Because I'm used to using a semicolon, but am I wrong? Interesting. Because I wanted to... Is a Boolean's correct? Code is right equals... Maybe like that? Maybe I had to make it a function? It's syntactically invalid, or you're missing something to complete this line. Oh, maybe you got, instead of, it's supposed to be equals like C++. No? Ah, interesting. So hold on, how to in GD script. Var test bool equals false. Interesting. So if I do that, okay. Oh, really? That you guys use? Really? Oh no, I don't like it. Var some bool. Interesting. So you have to use a var? Oh, sorry, I'm just playing around. Oh, hold on. What do you mean? Go quest.get wants to see no. What are you talking about? So if I run this. Okay, so now it works. Print. Yippee. I forgot the movie. There we go. Aw, man. You can't see the... How did they do it in the first one? When they printed, sorry. Yeah, print welcome. And it runs. So I wonder why it's not running this time. Oh, rude. It totally... Okay. Well, var code is right equals true. That sucks you can't declare a Boolean outright. That's really weird. Okay. How many lessons? Okay. Alright. Oh, there's 27. Holy shit. Okay. I will... I'm gonna take a break because I've already taken like an hour reading some of the documentation and then discovered this, which is absolutely amazing. So I might just do another video just going over my next like Godot study session will probably be me just doing this. I'm not sure. I'm trying to, as I'm like talking right now, I'm trying to think of how I'm gonna edit this because I feel like I don't know if this could just be an hour, over an hour. It just sounds kind of crazy having an hour-long video. Just me talking and talking over the documentation, learning as I go. I don't know if that's really a watchable thing. And I'm wondering if this could be like a sleeping aid thing or just like, oh, maybe you can have this on while you're learning or you're doing your own work. But then it's like I'm talking, so it's kind of hard to focus on something when you're talking. Or when someone else is talking, I should say. Yeah, I don't know. I don't know if I just want to leave this open or I'll just probably cut it a bit and see what stands out. Because again, this is just me learning and I'm just keeping a record and document of what I'm learning. So, obviously, this should honestly just be a sleeping aid at this point. I don't think it's anything spectacular I'm learning. It's just the basics of Godot and trying to understand. So, but yeah. Thanks for watching. I appreciate it. Hope. Actually, if you even made it this far, wow, props to you because I have no idea. This probably all sounds so boring hearing me talk it over. But I'm learning, so that's all that matters. Alrighty. See y'all in the next one. Bye.